Start the recording. Okay, thank you all for joining. So today we will be starting the second module in Azure. Especially this is important for two examination. One is Azure 104 administration exam and Azure 700 network engineer exam. So we are going to cover a lot of content. Okay, so we will start from the basics of networking, and then we will move on to discuss some of the virtual network related services components, and we will also discuss how to connect the virtual network with on-premises and other third-party network, and we'll also discuss how to establish VPN third-party appliances. So it is going to be a lot of content. Okay, so let's start from the scratch. So to understand why exactly we need to understand about the network or learn about the network, see, networking is a core component, right? See, without networking, you cannot talk to each other, right? So that is how you have the social network where you collaborate, you communicate with each other, right? Similarly, in Azure platform, you create something called virtual network through which you can connect between each other. See, you can connect two different virtual network, or you can actually communicate from your application to other Azure services, or you can also communicate between different applications or between virtual machines, right? Between VMs, or you can connect with on-premises network, on-premises network applications. See, some of your application will still reside on your mainframe or Unix applications or whatever, right? So those systems will remain on your data center on premises. So we need to connect the application that you have migrated to Azure. So you need a mechanism to do that. And besides communication connection, we also need to deliver the services. So when I say deliver, you are hosting your application, right? And when you host the application, that application should have to be accessed by your end users, your customers, your third party providers. So they need to access that application, and that application has to be delivered. And I'll come to the list of services that is used for the delivery portion, but application has to be delivered. And when you host some application, it also has to be protected, right? So it has to be protected. When I say protected, in your on-premises network, you might use network firewall, you might use some third-party services to secure what kind of traffic can be accessed, who can access, and all those things, right? So you need to protect your services at the network level. So security also is integrated to your network. And then comes the network level monitoring. So who is accessing, how much data is being transferred, how many users are connecting, from where they are connecting, what kind of traffic traverses through your network. So all those things has to be monitored. So when it comes to networking, so these are all the key areas that you should be understanding. Okay, how we are connecting two different virtual network, how we are connecting two different VM, how we are connecting our application on the Azure platform to your on-premises network, and how we are delivering the application to the end users, and how we are protecting the applications, and how we are monitoring the application. So these are all little core important topic. So we'll have to focus on these items. Okay, application protection, application delivery, network monitoring, and the communication. I would say these are all the communication related stuff. Right? So, and again, besides this, as you know, in your on premises, not all your application has to talk to each other, right? Some application has to connect to a particular web server or a database server, or certain application has to connect to a particular database, and all those things. So we need to uh, have a mechanism to do a filtering of your traffic. We need to have a mechanism to do a routing of your traffic, from where to where systems can connect, from where to where the packets can travel. So all those things has to be done in a controlled manner. So filtering, routing is also done at the network layer. So these are all the important stuff that we should be understanding on how it works in Azure platform. Okay, so now coming again to the networking, the very first thing you will create in Azure platform is your VNet. Unlike your on-premises, in your on-premises, if you want to do certain things, right? For example, if you want to communicate the systems between each other, you go and develop a you go and implement a physical network, and within that physical network you might have switches, you might have routers, you might have some hubs, modems, and all those things for connecting to internet, for connecting to different machines and so on. So this is physical networking, right? Where within the network switch, you go and create virtual LANs, VLANs, and then you use it for various purposes. So you can create VLANs for some different department. For a particular department, you will assign a particular VLAN like 100, 200, and so on, and or else like you will use it for different type of traffic. For example, you might use it for production traffic, backup traffic, replication, or clustering, and so on. Okay, so you might use VLANs for either segregating them into different departmental needs, or you might use it for different roles of the server. Like for example, you might use it for a separate VLAN for application, separate VLAN for database, separate VLAN for web server, and likewise, right? So there are different situations where you might create VLAN either based on the department, either based on the traffic or the role, or even sometimes for environmental needs like test, development, production, you might create a different VLAN. So this is how you deal it on your premises, on your data center. But here, the physical networking is completely managed by Microsoft. You don't have control on the physical networking. So as a customer, where our role starts, or where exactly we will be able to manage, or what we will be able to manage. So we will be able to manage only the virtual networking. So virtual networking in Azure is what customers can manage. So as a customer, if I want to have my own network, so you have to go and create a VNet. So VNet, you can call it as a private network space for each customer. So if you create a VNet, VNet is specific to a specific subscription. So for each and every subscription, you will have a VNet, and this is a kind of dedicated to a particular subscription. And why you are creating a virtual network? In order to get a logical isolation from other customers, in order to get a logical isolation from other resources. Okay, so virtual network gives you a way to segregate your entire network into small chunks, or into a logical isolation. In on premises, we used to do that using physical network getting segregated into logical network by VLAN concept. But here in the cloud, you create virtual network, and if you want to subdivide them, you want to have small subnet or segment, you create subnets. Okay, subnet is mainly for segmentation or for subnetting. In order to create some small chunks of network, you create subnets within that. And the VNet and the subnet are the fundamental building block for a private network in Azure. Okay, so what you are trying to do with virtual network and the subnet, you are replicating the physical network from your data center to a virtual network in Azure platform. So whatever physical network and the VLAN does for your on-premises, here in the cloud space, in the Azure space, virtual network and the subnet is going to do that. So if you ask me whether I should have networking knowledge to learn this, no, you don't have to really understand the physical networking concept, because physical networking is completely different, and you have a very detailed learning path for your on-premises. Here, the physical networking is managed by Microsoft. The data center networking is handled by Microsoft, whereas as a customer, our application should have to talk to each other. Our application should have to talk to the applications on the premises. So for which we should be able to design and implement the networking for any particular scenario. So I'll I'll explain what are the different scenarios we will come across when you work for a particular customer environment, and I'll show you how to deploy that, how to implement that in a practical way. For the next 3 to 4 sessions, it will be completely network only. So I will need at least 4 to 5 sessions. Sometimes it might go up to 5 to 6 sessions. So there is a lot of content to cover. So we are just starting with networking now. So when you start your networking journey in Azure, the very fundamental thing, the very fundamental building block for creating a private network is VNet. So VNet is a virtual network, or you can call it as a private network for a particular customer. This is a fundamental building block for creating a private network for a customer. Okay, and this is your own network. Okay, you can call the VNet as your own network in Azure data center or Azure cloud. So it is a logical isolation. So whenever you create a virtual network, you create it at a regional construct. When I say regional construct, your VNet is created at the regional level. So that means within a region, you might have multiple zones, multiple availability zone. So your VNet can have virtual machines in different data centers in that particular region. So when I say a particular service is a regional construct, it is created at the regional level. Some services like Azure Active Directory, they are all global construct. So they are kind of created and used across the globe. But then the virtual networks are created at the regional level and they are called as regional construct. Okay, so which means they can span across different zones, different availability zones to be specific. Okay, or I'll keep it this way. Okay, so you can let's try and create something. Let me quickly log into Azure and then I'll reshare my screen. Let me see where exactly is my portal. Just give me a minute. I'm just logging in and then I'll reshare my screen. Okay, I'm just getting a code in order to log in. Okay, 7097312. Okay, fine. I think I'm logged in now. I will go back to the home. Okay, let us see what are the resources that are there. Okay, fine. So now there will be a question, right? So until today, I'm meant
The
to share my
screen is
screen.
not displayed.
Yeah. I'm meant to share my screen. I'm about to share it, Subramani. Let me share it. So I'm sharing it now. You should be able to see it now. Yeah. So there might be a question, right? So I have not created a virtual network so far, but then I was able to create a VM. I was able to connect that VM from my on-premises. Even I was able to create a website in that VM, and I was able to access it through the internet and all such things, right? So in a nutshell, you are able to connect, you are able to communicate, and all those things. And how that was happening was your question, right? Well, might be a question for all of you. So whenever you go and create a virtual machine or a particular resource in Azure platform, so let's try to do that and then see what happens behind the scenes. So if I go and give it a name, so let's say Stan VM Stan Windows VM 001, and let me just select a particular operating system. Okay. So now if I go to the networking tab, you can see that it is automatically creating a new virtual network and a new default subnet and a new public IP address for my usage. So whenever you are creating a virtual machine, a network interface will be created, a VNet will be created, and a subnet will be created by default. Okay, that is how it works actually. So that means it is going with a default solution. It is not customer defined. So when you go and create something, it creates a default VNet and a default subnet plus a network card, and also it assigns a public IP. So default, a VNet will be created, a subnet will be created, a network interface card will be created, and a public IP plus a private IP will be assigned whenever you go and create a VM. Okay, this is how it was allowing us to connect to that virtual machine from the internet as well as from the virtual machines from the Azure platform. So these things happen by default. But now we don't want the default things to happen. Instead, as a customer, I want to have my own address space. I want to define what is the address space that I want to use, because see, in on-premises, that is what you used to do, right? As a customer, you go and create a physical network, you go and subdivide them into logical VLANs, and you use it for different purposes, right? And here similarly we want to do the same in Azure platform. So now, okay, see, as a on-premises data center engineer, what we generally used to do is we used to have our own networking space created by the network engineer. But in Azure platform, it is the responsibility of the Azure administrator to create the VNet, to create the subnet, and allow the connections to be handled. So I'll show you how the on-premises networking will be done, and how the network engineer will allocate the IP addresses, VLAN, and so on. After the break, I'm meant to open that file. I have some sample files. I'll show you how the network engineer used to do that for the physical data center. But here, this is logical concept, right? It's a logical isolation, logical networking. So as an Azure administrator, we need to take care of creating the VNet and also the subnet. Okay. So Azure VNet. Okay. So when you go and create a VNet, you need to have a IP address space, and that IP address range or IP address space, they call it as CIDR value range, or it will have a CIDR value for each of your VNet and subnet. So CIDR stands for classless interdomain routing value. So if you know little bit basics of network, you know that there are 5 different classes of private IP addressing, right? Class A, Class B, Class C, Class D and E, which are used for experimental and multicasting, and not multicasting, for R&D and all those purposes. But in customer environment, we generally go with Class A, B, and C. And within this Class A, B, and C, there is a documentation which defines what is the private IP address space that customers can use. So there is a RFC document 1918, which is managed and defined by an organization called IANA. Okay, so IANA is an organization which manages the IP addressing globally. So they call it as Internet Assigned Numbers Authority, and even you can call them as Naming Authority. But this is an organization who defines what kind of IP address should be used for public, private, and what are the ranges that is allowed. It is a documentation that is available on the internet. So if you go to RFC 1918 from IANA, you will find that document in the internet. So if you, this is the RFC document, and even if you go and look at the document in IETF, so they call it as Internet Engineering Task Force, right? So this is a global organization, and they are the ones who define what kind of IP address we should use on the private, public, and all those spaces. So here, if you open it, you can see this is the document that I'm talking about, request for comments 1918 document. So RFC 1918 document was created way back in 1996, and we are still following that particular standard for allocating the addresses for your private network in the internet space, in the public cloud. So you can go through this document. It is a pretty long document, but so they have decided to use 3 blocks of IP address space from 3 different classes. So we will just copy this to save the time. So let me paste it here. So these are the 3 IP address range that you might see in different organization for private IP addressing. So whichever customer you are working for, you might see only these 3 ranges. Okay, but how they are deciding which address range or which address block to use, right? So that is an interesting question, right? See, when you go to your browsing center or maybe like a cafe or like a internet in what do you call airport or lounges or whatever, right? They might use this 192 range. Even at your home or in a small office location, you might use the 192 range because it is a small span of IP address. And in class B, it is like used for medium sized company to large size companies will use 172 range of IP address. So large to very large organization which are globally scattered across will use the class A range. So if you think in this aspect, you can relate it, right? If you are working for a very large organization, they might already be using class A range, 10 range. If you are working for a mid-sized organization, they might be using 170 to 16 range. And if you're connecting from home or connecting from a small office location or in a front office location, they might be using 192.168 range. And what is the difference here? See, if you look at here, they are using different CIDR value. So this anything after that slash 8 slash 12 slash 16, right? So this is what they call it as CIDR value. So I'll explain how the CIDR value is derived and how you can relate it a little later. But so CIDR value in this particular range is slash 8. And then in this range class B we use slash 12, and then in class C we use slash 16. So these are the CIDR value. I'll explain how it is being used. And okay, in a small quick briefing, what I can tell you is, see, currently we are still using IP version 4. IP address versioning, there are two versions available. IPv4 is there, and then IPv6 is there. IPv6 has been in the market for the last 10 years, but the usage is not still there. So IPv6 came in to the picture where a lot of systems started growing, and IPv4 started. I mean, we started seeing a complete usage of the IPv4, and that addresses more addresses were needed, and that's the reason IPv6 was brought in to have more bits and more systems, more IP addresses. Okay, so in IPv4, as you know, there are 4 octets, right? In an IPv4, you might have seen 10.1.2.3 or something similar to that, right? In an IPv4, you used to have 4 octets, or you can just say 4 digits separated by a dot in between, right? That is how IP addresses used to be. And in class A, if you are saying slash 8, so within an IP address v4, you have 32 bits, right? 8 bits dot 8 bits dot 8 bits dot 8 bits. So total of 32 bits are available in your IPv4. Okay, and out of this 32 bit, what is given to the network and what is taken for the systems to be assigned? Okay, in class A, you are telling that I will give the first 8 bit for the network, which means this will be consistent on your network. For example, the 10 will not be changing across your systems in your organization, but whereas the remaining 3 octets or the 3 portions will be changing from system to system. So that is what you are referring. In a large organization, you will get almost 24 bits for your systems, for your host. So H stands for host, N stands for network. So for your network, you are saying I will assign only the first 8 bit. So the 10 will be constant across your systems, whereas the remaining stuff will be assigned, can be assigned to the host. That is what you are conveying in slash 8. Similarly, in slash 16, you are saying the first 2 portion will not change between my system to system. See, 190 to 168 will be common across all my systems, whereas the host, the systems, the laptops, the desktops, the printers or whatever will get an IP in the last 2 octets or in the last 2 separated items. So here in class B, you have the second octet shared between network and host. So that's the reason you can see 172.16 until 172.31. So you can see that it changes from system to system. So this is how it has been defined, and based on your organization size, you can go and use the different IP ranges. And again, some of you might be very optimistic, right? So I'm starting a company. I feel like my organization might become a global organization in some time, and my systems will be created. Like I might have a lot of systems in the future. So should I go with 10 range or 172 range? Might be your question, right? See, when you go and create a larger IP space or a larger IP networking, so the broadcasting will increase. The broadcast or the IPs getting connected will slow down in a larger organization. So if you have a smaller subnet, smaller segment, you can connect between them much quicker. The broadcasting traffic will be very less, and you can have a much better latency. But I'm not telling that you should not use the 10 range or 172 range. You can definitely use whatever IP range based on your organization size, current size, and the future forecast. Okay, now for defining a virtual network in Azure platform, we should use either of these three. Okay, so see why. What are the different cases we might need to create a VNet in Azure? So there might be a dedicated private network that is needed. In some organization, you need to create a private network and a public network, and the public network will have the web servers and the internet facing applications, whereas the private network will have the app servers, database servers, and so on. In some cases, you might need to have a hybrid model. For example, on premises, you might have mainframe systems, Unix system, and you have to connect from the Azure platform to the on premises. So there are a lot of scenarios, a lot of use cases. I'll list all of them one by one. But before getting into the scenarios, use cases, I'll help you with how to define a VNet, how to define a subnet, and then how to use them for assigning it for your Azure services or your Azure systems, right? So let's start doing that. And see, as a Azure administrator, you need not be thorough in subnetting or how you do networking, but still a good understanding will help you in the long run in also troubleshooting as well. So let's try and do something here. Let's try and create a small calculation before we go and assign the VNet or before we go and create the systems, right? So let me help you with a small subnetting calculation. See, these days, I know a lot of websites have come, and you really need not do all this calculation on your sheets and stuff. You have a lot of IP subnet calculator available in the on the internet, which can give you the details in a button click, right? But then I prefer to have some level of understanding or some understanding on how these things gets created and populated. I would say like you need to have some level of understanding, if not at least a basic understanding. Okay, if not detailed, you can have a basic understanding. Now let's say you have a customer who has reached out to you stating that they want to have some specific VNet created and for their application, for their databases and so on, right? So let's say I have a customer name Antos, some particular organization, and for this organization, they are saying they are a startup company or a mid-sized company, and they want to have some specific number of IP addresses. So the number of IP addresses has to be derived by a particular format. Okay, you cannot just decide on that very easily. But then I'll tell you. So as I told you, you might have segregation either by department or server role or environment and so on. So you can create it for different purposes. Okay, so let's say this particular company, they want to have non-production, production, and the QA environment separately. Okay, so let's say prod, development, and then test. So they want to have three different environment segregated, and each of them will have their own IP range. Okay, so as a customer, okay, so we will ask them what is the number of IP address that will be needed. Okay, in certain cases, one particular virtual machine can have multiple IPs. It might have multiple website binded to virtual IP addresses or multiple IP addresses. So You need to understand, you cannot just assume that the number of servers is equal to the number of IP address needed. No, it's not like that. Some systems might have 3 IP addresses, 4 IP addresses, and so on. So you need to understand how many IP addresses you need from in total. Okay, so for example, customer is saying to me that he might need up to 50 systems, 50 IP address in production, and maybe like 25 in development, and they might need some 15 IP address in the test environment. Okay, just an assumption. Okay, so we will start with a smaller number. Maybe the second calculation we will use higher number. So we'll try to understand how the calculation works first, and then we will go on with little higher number so that we can break our heads. Okay, so let's start with a smaller number now. So this is what a customer has told me, that they need 50 IP address for production, development 25, and test 15. Okay, so now there is a formula for how we can do a subnet, or how we can derive a subnet. So now for Antos organization, we will create Antos VNet, and within that VNet, customer has said, I need subnetting, or I need the subnets to be created for different environment, for production, dev, and QA. So in some customer will say, I need a separate subnet for web, for application, for database, and so on. So you can create it based on the role, based on the environment, based on the department, and whatever use cases that the business owner, the customer, is deciding. So here I have went with the environmental split up, environment based subnetting. Okay, and the formula that we have to use is 2 power n, right? 2 power n is a pretty straightforward formula that we might have been using for a very long time, or we are known about that even in colleges, and nowadays schools also is teaching that. So 2 power 0 is 1, and you can keep writing. So 2 power, anything to the power of 0 is 1, and 2 power 1 is 2, and 2 power 2 is 4. So we will write the formula until the number that we are looking here, right? So let me say 2 power 3, 2 power 4. Okay, let me write until a few numbers here so that we can do the calculation in the sheets itself. So let me stop here, okay, until 8. So you just have to double the number because it is to the power of 2, right? So 1, 2, 4, 8. It's basic mathematics, right? 16, 32, 64, 128. I'm just doubling it by 2. Okay, now here I need 50 IP addresses for production environment. So you cannot do the calculation or subnetting by going with these numbers. Instead, we should find the nearest um, subnet, or the number which we derived out of the 2 power n formula, right? For 50, see, I can go with 64, or I can go with 128. And the simple thing that you need to do or understand, whether there is a requirement to expand in the near future. If there is a room for expansion, then see, customer has asked for 50, and if you're choosing 64, there is only 14 IP addresses, and within this 14 IP addresses, 5 IP addresses will be used by Microsoft for connectivity, routing, and all those purposes. So if that is the case, then we are neck on neck here. So what we can generally do is we can go and choose the next subnet, like, which is 128. And some of you might ask, why not 256? Why not 512? Why not 1024? Right? So if you are increasing the number of IP address, the broadcasting will increase. So if your system has to connect to another system in the same network, it will have to find out whether there is any conflict in the IP, whether the which machine has got that IP, and the networking latency will increase. When the broadcast traffic increase, the network latency increase. So you should not go and choose a higher number just for the sake of expansion, or just for the sake of future requirement. Okay, so you should try and stick to some of the basic requirements for now, and maybe like you can be a little more. I mean, you should be conservative, but you can also be a little more careful in allocating it. You can go for either 64 or 128. So if you're going with 32, the number of IP addresses that is needed is more than that. So you cannot choose 32. So you should go and choose 64, or maybe possibly 128. So here I'm going for 64. Okay, and in the next case, in the development case, I can either go for 32 or 64, right? So if I go for 32, it is more or less like neck on neck. I'll tell you the reason. Again, for 15 also, I can go for 16 or 32. See, one IP address will not be sufficient. The reason I say that, for each subnet in Azure, Microsoft will utilize 5 IP addresses from each subnet or each subnet. Okay, so I'll tell you what are the specific IP addresses that Microsoft will reserve. So Microsoft Azure will reserve and use 5 IP addresses from each subnet. It's not from the VNet, it's from each subnet. Okay, for example, the very first IP address, first IP will be the network range or the network ID, or they call it as network address. Okay, and then the second IP address will be your default gateway. So it will be generally used for routers and L3 switches in your on-premises. And here the third IP address will be used for reserved for like services like DNS or some networking services. And again, the fourth IP is also reserved for networking related services. And the last IP in your subnet will be used for broadcast. So they call it as broadcast ID or broadcast address. So from each subnet, Microsoft needs 5 IP address. First 4 IP address will be reserved and the last IP address will be reserved. So if that is the case, then here if you look at 25, so you need ideally 25 IP address for the customer and 5 IP address for Microsoft Azure data center connectivity. So that means you are already using 30 IP address. So you are leaving only extra 2 IP addresses for the future requirement, but that's fine. Okay, so here for the calculation you can go with this, but in real production environment, I would suggest to go for the next range. So if let's do that actually. So here I will be a little more cautious and I'll go with the next range so that you get a lot of free IP address. Is there a question? Okay, fine. So now I have derived, see, as I told you, you can use 64 or 128. You can use 32 or 64 for each of the requirement, but I have given little room for the future requirement. But but you can be you can be fixed to what customer is asking from you. You can just limit the range for 32 or something like that here itself. Okay, now as I told you, here Microsoft Azure will need 5 IP address. Okay, that means 50 plus 5 is 55. 25 plus 5 is 30 IP address. 15 plus 5 is 20 IP address. So my customer needs 50. Microsoft Azure data center interconnection needs 5 IP address. So total of 55, 30 and 20 is the actual need from each subnet. So you need to decide whether these ranges, whatever you have chosen, is above this particular combination, customer need plus Microsoft Azure need. Otherwise, you might end up with losing a lot of IP address for the customer. So you have to be careful here. So now, so I've chosen 128. 128 is equivalent to 2 to the power of 7. So the formula that I've chosen is 2 to the power of 7 here. And for 64, the formula is 2 to the power of 6. And for 32, the equivalent is 2 to the power of 5. So there is a reason why I am adding those details here. So the reason for adding the details here is to identify the CIDR value for each of your subnet. Okay, so it is pretty much easy. Okay, so CIDR value is derived like this, right? As I told you, CIDR is mainly to distinguish what is given to the network, which means your switches, routers, and for the interconnection, and what is allocated for your systems, for your application servers, web servers, for your laptops, desktops. So that is what is assigned to your host, right, for your systems. So here, what Microsoft or customer need plus Microsoft need is demanding is 7 bits. Out of the total 32 bits in IPv4, you got how much? You got 32 bits. and out of the 32-bit, the network, they are asking 7 bits. So you have to subtract the 32 minus 7, and that is what is being assigned to the network here. Okay, so 32 minus 7 is what? 32 minus 7 is 25, right? So that is what, yeah, 25. So that is what you are going to get for your systems here. So slash 25. And similarly here, 32 minus 6 is your 26. So we are just doing a very basic mathematics, right? So 32 minus 6, and then we are just saying 32 minus 5 is 27, right? So this is the CIDR value for each of your subnet. For your prod subnet slash 25, for your dev subnet slash 26, for your test subnet, it is slash 27. And from this CIDR value, you can also derive the subnet mask. I'll help you how to find out that subnet mask shortly. But before that, let's go and find how many usable IP address from each of these ranges. Okay, so now usable IP addresses can be found by subtracting the total IP addresses from the IP addresses that Microsoft needs, right? So Microsoft needs how many IP addresses from each subnet? 5 IP addresses. So 128 is the total for the prod subnet, and out of the 128, 123 can be used for customer specific IP addresses, right? 123 IP addresses can be used for customer. And from 64, if you subtract Microsoft need of 5, you can get 59 IP address for your development systems. And similarly, for your test subnet, out of the 32, if you subtract 5, so you will get up to 27 IP addresses for your customer need. So you are getting a lot of IP address, and it is definitely sufficient for the customer requirement. Okay, these are the list of usable IP address. Now, if you want to find out what is the first IP, last IP, and the range of IP addresses that can be used for your network, so what you have to do is you need to choose a particular class range. Okay, before you go and identify that, you need to choose a class range. See, this is a very small organization or a startup, so you can choose anything in this range: 192 168 0.0 or 1.0 or 2.0 or whatever. You can choose from this range. So let's say I'm just choosing 192 168 0.0 as my overall VNet, and now 192 168 0.0 is my first network ID, and within that network ID, okay, so I'm just rewriting it again along with the CIDR number. The CIDR number is slash 25. I'm just adding that here along with your specific subnet for your prod subnet. Okay, 192.168.0.0 is your network ID. It is the first IP address, and the usable first IP address is for the, I mean, not for the customer. So for the gateway, for the default gateway, 192.168.0.1 will be your default gateway. And what is the reservation 1? So reserved 1 is 192.168.0.2. And similarly, reserved 2 for networking is, it can be for DNS or for network virtual appliances and so on. So 0.3 is for your reservation 2. So first 4 IP address is reserved, and also the last IP address will be your broadcast IP address or broadcast ID, right? So the broadcast ID will be what? So the number starts with 0, okay, and the overall range is 128. So if it starts with 0, 1, 2, 3, and if you are counting 128, so the number will end with 127 because we have started with 0. If you have started with 1, it might have ended with 128. But since you have started with 0 as the network ID, the IP addresses generally starts with the network ID as 0, and then it goes up to 127. So I'm just writing the same thing here. So a total of 128, and since it starts with 0, it will end with 127. So what is the last usable IP address for the customer? 192.168.0.126 is what customer can use in this particular production subnet range. And what is the customer first IP address? It is 0.4 and then 5 and then so on, right? So customer second
Sir,
IP address. Yeah, go ahead, go ahead.
sir, is the production is that 50 is the host address, sir. So total host address is the 15 is the 128. So,
Yeah, see, customer needs only 50, but then see, if I went for 64 IP address, then it might have started with 0 and ended with 63. But then I want the future requirements also to be covered. So I went with 128
okay.
as the number. Okay, so that's the reason you are getting 128 IP addresses range here. Customer only needs 50 for now, but maybe like they might need more IP address in the future. So that's the reason I went with little proactive approach.
Okay.
Okay, so the first public subnet or the prod subnet has ended with 127. So the next subnet will start with 128. Okay, so that is how it generally works. 128 slash, you can just give the same CIDR here, whatever I have written here. So that is the CIDR that I have to write along with your subnet. Okay, so here in this case, the very first one will be your broadcast, network ID 192.168.0.128 is your network, 129 is your default gateway, 130 is your reservation 1, reservation 2 is 131, 132 is customer first IP, 133 is customer second IP, and the last usable IP address will be derived using this value. So 128, it starts with 128, and how much we have? 64. 128 plus 64 is how much? 192, right? 128 plus 192. Yeah. So it is 192. So 192.168.0.191, because we are starting with 128, so it will end with 191. Even though it is 192, it will end with 191, because the same thing, same formula. Like if you start with 0, even though it is 128 IP address, it will end with 127, because we have started with 0. We have included that. Similarly, here in this calculation, we have started with 128, so the last number will be 191. And what is the one number before that? So it is 190, right? That is the last usable IP address. I'll show you how this works after creating the VNet, right? Similarly here, 192.168.0.192 is your next IP, and that is what we are going to use as a network ID. And even in the calculation, that will be /27. I'm just writing whatever we have derived as a CIDR value after the network ID. So now 192 is your network ID, then the gateway is 193, reservation 1, reservation 2, customer first IP address, customer last IP address is 197. And how you will decide the broadcast ID? 192 plus 32. It is 224. So one number before that is 223. So it will end in 0.223. And what is one number before that? 222. That is your last usable IP address for your test subnet. So this is how you derive the IP ranges for each of your subnet. Now we have found the subnet range for each of your requirement, but we did not find the overall CIDR value for your virtual network. So we have found it for each of your subnet, but for the entire VNet, we need to identify. So how do we identify the overall VNet requirement? You need to add all these IP addresses together. It is a total of 224. The sum of all these are 224. So if we have a range of 224 IP address across the subnet. So we need to go and find out which will be suitable for that particular requirement. For 224, 256 is what is suitable. So we will write 2 to the power of 8, and which is equivalent to 256. This is sufficient for us. So now how do we identify the CIDR for Antos VNet? So 32-bit minus the 8-bit. 32 minus the 8 bits, whatever we have chosen, is what? they are asking us to give it for the network. So remaining whatever 832 minus 8 is 24. So 24 can be used for our systems, right? So that is how we derive the CIDR value. So the total number of bits, 32 bits, minus what is being asked by the customer is what we will give it back to the network. So it is the slash 24, 32 minus this number. Okay, now coming to the subnet mask calculation. So we have not found the subnet mask here, right? Subnet mask is pretty easy to calculate. It is pretty much a similar calculation like 2 to the power of n.
Understand?
Yeah, go ahead.
One question.
Yeah.
How we select this 192.168?
Based on the customer sizing, customer
Yeah.
requirement. See, for example, for a browsing center or for a cafe or a lounge or a airport or a small home network or a small company, you generally go and choose the class C. And for a medium to large size organization where you need a lot of IP address, like for example, up to this much range, then you go for the second range,
Okay.
and so on.
Okay. Got it.
Yeah.
Thank you. And this is for we are doing it for the private IPs in our
Yeah, only for the private IP address. Yeah. So there is a documentation called RFC 1918, which is written by the IANA organization in way back in February 1996. So that is the same documentation we are still following. So if you refer to this RFC 1918 document, the request for change 1918 document. So this is the range that they have given.
Okay. Thank you, Stan.
No problem. Fine. Yeah. So let me just also, I think I have some more information here. Let me quickly check. Yeah. Okay, I'll come to that slide a little later. Yeah. So here, so we have chosen 192 because we are just looking for a very small range of IP address, and we went with 192, 168. But you can choose even 10 or 172 range if you feel your organization might have a very good growth pattern in the future. Okay, so now coming back to the subnet mask, what we were trying to derive. So for subnet mask, there is a small calculation. Okay, so we wrote all these numbers, right? 1 to up to 256, right? I'll just copy the same numbers here. Okay, and then I will so we are looking for only 8 bits. Okay, 0 to 7 is 8 bits, right? So we'll just copy that numbers, and then I'll try to paste it. Can I do a transpose value? So this is the transpose, but it is left to right. Okay, fine. Okay, let me. So I'm just writing it from right to left instead of left to right. Okay. Fine. So now I have written the same numbers from right to left. I should have done it straightforward. I thought the transpose will help, but it is transposing from this way. Okay, so I've written the same number. So total of 8 bits here. Okay, so from 1, 2, 4, 8, 16, and I've just copied and pasted the same thing from 0 bit to 7th bit, which is total of 8 bits. So here, for a total of 8 bits, now what is customer asking for them? So here we have got /25, right? /25 is what we have got, and we have got, let me just copy paste this here for easier reference. Okay, I'm just going to copy paste the same thing here at the bottom. Okay, so now Control X, Control V. Okay, so there is a total of 32 bits in IPv4. Okay, out of this 32 bit, 25 bits are being asked by I mean, 32/25 is what we have found, and 2 to the power of 7 is what customer is asking here. So now, how do we put that in a subnet mask format? So in IPv4, we have got 32-bit and a total of 4 octets. So when I say 4 octets, 1 octet is equal to 8 bits, right? That is what we have learned in the basics of networking, right? So total of 32 bits, which is comprises of 4 octets. 1 octet is equal to 8 bit, right? That is what we have learned in the past, right? So 8 bits dot 8 bits dot 8 bits dot 8 bits, and out of this, what customer is saying that they need only /25, right? So /25 means 8, 16, 24, and from here they just need only 1 bit in the last range. So I'm just writing the /25 number in terms of bit. I'm just adding it. See, for example, 8 plus 8, 16, 16 plus 8, 24, plus I'm just going to write only 1 bit. Remaining 7 bit, the customer is going to use it for their systems, application or domain controllers or whatever requirement. This 7 bits will be used for systems. The remaining 25 bits will be used for the network. So how I'm going to write it? 8 bits dot 8 bits dot 8 bits dot 1 bit. Okay, this is what we have derived based on the actual requirement. Similarly here, 8 bits dot 8 bits dot 8 bits, and the last one will be 2 bits. So if you add these things, the CIDR number should match. Okay, the CIDR value should match. 8 plus 8, 16, 16 plus 8, 24, 24 plus 2, 26. So I'm just writing it in bit or in an octet format. Okay, here 8 bits dot 8 bits dot 8 bits dot 3 bits, total of 27. So this representation is what we call it as subnet mask. Maybe you might start asking, like, I've never seen subnet mask like this. Yeah, so you might not have seen like this, but instead it will look like this. So 8 bits, total of 8 bits is this. Okay, if you sum all the 8 bits, the value that you get is 255. Okay, so this is you are adding all the 8 bits and you're going to write the equivalent here, 255. Equivalent of 8 bits, 255. Equivalent of 8 bits, 255. Equivalent of 1 bit is 128. So here again the same thing, 255, 255. In the last octet, we are having 2 bits. You have to add the 2 bit from the right to left. Okay, so it is 192. See here on the bottom in your Excel, I'm seeing the sum value here. It is 192. Okay, so it is 192 for this particular subnet. And similarly here, it will be 3 bits. So I have to add the 3 bits from right to left. So if I sum those, it is 224. So this is what is your subnet mask for each of your subnets. I can copy paste that here and we can verify it later. So subnet mask is this, default gateway is this, and you got the list of IP address that are usable. And for your Antos VNet, you have got /24. So /24 is what? 8 bits dot 8 bits dot 8 bits dot 0 bit. 8, 16, 24. You are already done here. So if you write it in subnet mask, 255, 255, 255.0. That's it. Okay, 0 bit is equal to 0. Now let's go and do the same thing in your Azure platform. So I'm going to create a virtual network. Go and search for virtual networks. So in virtual networks, I'm going to create my first VNet. So VNet is mainly for connecting your Azure resources to each other or to your on-premises network. So mainly it is for connectivity, for secure connection, I would say, either to on-premises or for connecting to other systems. So let me create it here. So let me call this particular VNet. So I'll just select the resource group and then I'll call it as Anto VNet 001. Okay, so Azure VNet is the fundamental building block. All those things we have already told, but I'll just copy paste it for your future reference. Fine. So now I've just named it Anto VNet 001. Next, here is where you decide whether you need a bastion. So last week or last week only, we discussed about the Azure Bastion concept to secure your connection to virtual machine. If you want to enable it now, you can enable it. But for now, we can skip the Bastion and firewall. But now the important thing that we are concerned is about your IP version, IP addressing. Okay, so you can go for either IPv4 or IPv6. For now, still most of the customer are stuck with IPv4. So we have done a calculation for IPv4. So we will use the IPv4 for calculating. So Azure VNet, it supports both IPv4 as well as IPv6. So supports both IPv4 addressing and IPv6 addressing. So your Azure VNet, it supports both. Okay, now coming to the calculation. So what is the overall CADR that we have identified for your VNet? For your VNet, this is the number we have derived 192.168.0.0/24. That /24 you can just populate here on the right. So if you go and select /24, automatically you will see that how many IP addresses are supported. That is what we were expecting, right? We are expecting a total of 224 IP address is what customer is needing, and we were expecting 256 based on the formula. And if you look at here, that is what you are seeing, 256. Now we have to go and create different subnet for your customer requirement. First one, they have given a label of default. I'll just change it. I'll just change it to prod subnet 01, and then the IP range that we have chosen is 192.168.0.0/25. /25 is what you have to choose on the subnet sizing. So you can see that it is supporting 128 IP address. Okay, that is what we were expecting. Now I can just go and save this one. Similarly, I can go and create more subnet in order to, you can also add the subnet later also. Now I'll show you how to add two subnets, and then later I'll show you how to add the third one. So for development, I'll just say development subnet 01, and the starting address will be this one. So starting address and the network ID are the same. And what is the subnet CADR/26? Okay, fine. See, you can easily understand here itself. Okay, so starting from 128 until 191, that is what we were also expecting, right? So starting from 198 to 128 to 191. So it's pretty much what we were anticipating. Fine. So now let's add it, and let's review and create. The third one I can show you how to add it later also. You can modify the address space later as well. So let me go and create it. Create. Okay, so VNet virtual network is getting created. Along with the virtual network creation, there are two subnets that are getting created. I'll show you how to add the third subnet shortly. Okay, done. Now, if you go and refresh, you should start seeing that. So now overall the address space is 192.168.0.0/24. You get an address count of 256, and this is what the CADR notation says. And we have chosen the private IP address from where? RFC 1918 document, and they have clearly mentioned the address space for a virtual network is comprised of one or more non-overlapping IP address. So you cannot have subnets with overlapping IP address. So it should be contiguous, or it should be non-overlapping. Okay, so that is very, very important. Now you can see that we already have created two subnets, and I can add one more subnet here. So what is the last one? Test subnet, right? So test subnet 01. And I can give the range here. See, automatically Azure Console, it picks up the next IP address automatically. Okay, so if you just look at here, see, it has automatically picked up the next IP address. Only thing is we need to select the subnet based on our requirement. So here my requirement is /27 only, not 28. So see, clearly they are showing that you will get 27 for customer usage and 5 IP address will reserved for Microsoft requirement. What is that Microsoft 5 IP address requirement? Network ID, gateway, reservation, network reservation 1, network reservation 2, and the broadcast. These are the 5 IP address they will take, Azure will take. So it is pretty clearly defined, and you can see that this is what we were trying to do it on the Excel sheet, right? That is what we saw some time back. It starts with 192 and then it's end with 223, and out of which this one and all these ones will be used for Microsoft. Remaining this range will be used by customer. Okay, fine. Let's go and save it. So we have created a VNet, we have created 3 subnet, and you can keep creating based on your customer requirement. So now let's try and create a system. Okay, this time we are going to create a virtual machine with meaningful subnet, and we are going to select the customer defined, the customer created private network. Earlier, whatever we created, it was on the default VNet and the default subnet. Now this time we are going to create the system within our range. So now as a customer, if I want to have a development system VM001, okay, let's say we need a development VM, and let me just choose whatever that is there, and then here I will just select fine, this is okay. Okay, now we have to carefully choose the networking. See, this is the beauty of Azure's log or logging algorithm, or maybe the backend algorithm. It has automatically selected the VNet that we created, and it also selected the development subnet based on the naming convention. So most of the times it works very beautifully, but then sometimes you have to be very careful whether you are choosing the right subnet or not. So you have to choose the proper subnet, proper virtual network. So here it has uh, simplified our job very much, and it is able to select it from here. So now if I go and create it, review and create it, so what I'm expecting here, so the IP address of this particular VM will be what? It will be first IP address, customer first IP address. 192.168.0.132 is the IP address of that particular VM. This is the VM1 that we have created. So this is what we are expecting. And the default gateway is this, and then subnet mask is this. So we will find out whether we are getting the anticipated range. Let's see. Let's wait and see, and then we will confirm. So once after the VM is created, we will be able to find that. So you have two options to find it out. You can directly find out the allocations here. If you go to your virtual network under the VNet, so you will find out what are the connected devices. If I go to the connected devices, you will see a new network card assigned, and see this is what it has assigned: 192.168.0.132. So this is what we were expecting, that VM's network card to get it. Okay, similarly, if I create a next VM, it will get 133, and it will assign a sequence until the last usable IP address 190. And if I want to change it to static, I can also do that. I can use any range within this particular specific range. See, for example, I want this network card to have a static IP address. Currently, it has given a dynamic IP address based on the range. See, for example, I want to have an IP address like a fancy number 188 or 133. If I want to have that, I can have it. But if I want to have some other IP then I cannot assign it. I have to have a static IP address only from this range only. See, let's try that. So let me go to IP configuration. Let me go to IP config of that network card and then try to change it. So here I've chosen this subnet, and which means you have the option to only assign the IP address within this range. If you change the subnet here, then you can choose a different IP address. See here, if I go and say static, and it will only allow me to assign an IP address from within this range. So I can assign 135 or 188 or 190 or whatever. But if I say 200, it will throw out an error for me. So let's try that. I'll say 200. So it will say it's not in the subnet address space. You have to be in this address space. So let me assign 188. So it will work. Okay, so this is how you can change your IP address from dynamic to static, and you can use it. See, generally there are different use cases, right? Scenarios where you might need to have a static IP address. So what are those requirements? So let me start giving those inputs. See, in an organization, there might be cases where your web application or your production systems might need to have a static IP address. So static IP address means what? It will not change when you restart your system. It is constant, right? It's a fixed IP address. It's a permanent IP address kind of thing. Okay, so why we need a permanent IP address? See, for example, you might have systems like domain controllers, or you might have systems like DNS servers. So these are all systems which are pretty much works via the DNS resolution, right? So whenever you need to go and update a DNS record or a DNS host record, so those applications or systems wherever you have a URL binded to an IP address or a system binded to IP address, so you can go and update with the static IP address. See, even for certain Citrix systems or some applications, you'll buy a TLS or a SSL certificate. So these SSL certificate, transport layer security or a secure socket layer certificate, it will be linked or it will be binded to a IP address. So for such cases, you need to have a private static IP address. Okay, so because the licenses certificates will be binded to the IP address. Even if you have some on-premises system connecting to Azure, so you might have to write a firewall rule, right? Allow this particular on-prem system to connect to Azure resource and all those things, right? So if there is such requirement, you need to write a firewall rule to allow the traffic from the source to destination. If your destination is keep on changing, then you will have issues. So if you have a firewall in between, if you have to write a rule based rule based allowing denying, then you can have a static IP address. So a lot of customers will have similar requirement. So these are the top 5 use cases that I have seen, but there are a lot of reasons where your application might need to be having static IP address. You might have your web servers URL directly connecting to backend IP. So in such cases, you cannot frequently change your IP address, and for which you need to have a static IP address. Okay, so this is how you come and change the static IP address. Let me go back and then see whether it has changed. Yeah, it has changed. So now I can go and show you one more maybe quickly. Let me create one more virtual machine.
Sir, I asked this one.
Yeah.
Yeah, that's IP will be set up there, and again will be configure and troubleshooting this Bastion will be used, and another thing will be used.
So Subramani,
Will
see,
be
in Azure platform, you should never change IP address within your operating system. You should only change it on the Azure platform. Second thing, Bastion is different. Okay, Bastion server, it will be a separate system. It will have its own IP address, and from which it can connect, irrespective of your IP address. See, even if you have 20 systems within your VNet, all the systems can be connected from your Bastion server. So it can have an IP address of 130 or 140. It is immaterial for your Bastion server. So your Bastion can connect to all the systems in that VNet, irrespective of of the IP address, whether it is static or dynamic. It will still allow you to connect to the backend. Okay.
but how to troubleshoot this? Let's say.
Sorry, how?
How to the troubleshooting that commands will be configured or troubleshooting our switches or routers.
Come again. I did not follow that. How to troubleshoot?
Yeah, create the virtual machine is okay, sir.
Mhm.
I create the one router and switches or firewall guns. Then I configure our troubleshooting and again separate tool will be used or
Okay. So you are
some other
talking about the next level of stuffs, right? See, as of now, we have not come to application protection or application delivery or network monitoring. So we have not come to that part. We have just created a VNet. We have just created a subnet. I'll help you with a lot of different tooling and services. See, for example, when I talk about application delivery, you can allow the systems on the VM can be connected through load balancers to your end users. Even your end users can use application gateway. Your traffic can be done through traffic manager or CloudFront or Friendor. There are a lot of services which helps you to deliver the services to your end users. Your end users can connect through load balancer or application gateway or traffic manager or whatever. Similarly, your application can be protected at the network security group or network address control or DDoS protection or WAF, or there are a lot of different services that are available. Similarly, for monitoring, for your question, you can use Azure Monitor for troubleshooting, for Network Watcher for watching your packets, or Express Route Monitor is there for connecting for watching your on-premises connectivity. You have network tab. You have a lot of services to monitor and troubleshoot. We'll come to that little later. Okay, let's understand the basics first, and then we'll go there.
yeah, okay,
Yeah,
thanks.
sure. So coming to the basic thing, what we are trying to do, we created a network. We are trying to find out whether we are getting the IP address from that particular range. Okay, now here if we expect, okay, it is selecting the dev. Okay, but what was our plan? Okay, we did not give anything. So let's say test VM01. Okay, so now you have to be careful because we did not give anything. It did not select that, but now I have changed it to test. You have to be very careful. So you have to select the right VNet, right subnet. So now let me go and review and create it. Now what I'm expecting for this machine should get an IP address from the test range, and the IP address that I'm expecting is 196 for that machine. Okay, let's see. Meanwhile, while that machine is getting created, we will also go and connect to the other machine. Okay, so we created this one, right? What 188 is what we assigned. We will go and check what is the subnet mask, what is the default gateway, and all those stuff. Right, 192.168.0.188. Okay, so now I've created a VNet. I have created a system. One second.
It won't connect, right?
Yeah. One second. Let me just respond back to the chat. Yeah. Okay, correct. Okay, that is what we need to check. So private IP address is used for connecting from your Azure only, or within your VNet or within your systems. Okay, so there are two IP address. So private IP address and you have public IP address. So you need to distinguish the usage of these two IP address. So private IP address is only for internal connection within Azure, or through VPN you can connect from on premises or from your data center. Okay, so generally this private IP addresses you assign it for on-prem connection, or even you can use it for connecting through. Sorry, you can connect it through VPN gateway, or you can use Azure Direct Connect. They call it as Express Route. Okay, so these are the different scenarios. You can use the internal IP address or the private IP address. Private IP address, you can connect from one server to another server within Azure, or through the VPN, you can connect from on-premises data center network. And public IP address is for internet facing. So if you want to connect from home network or from internet, you have to use the public IP address. So even you can use the Azure public IP address to connect to Azure public facing services. There are certain services within Azure which are facing internet. Now, as a architect, as a administrator, our primary duty is to restrict the exposing, or like you should not expose any of your machines to the internet directly. You should try and restrict the access to the internet as much as possible. Now, if I want to connect from my home, then what I have to do? I have to use the public IP address. We already discussed this in the first class, but then again, we'll just try and understand. See here, we have a public IP address, we have a private IP address. So private IP address, if I am connecting from the other VM, I can use this IP address. But if I want to connect it from my home, I have to use this. So it is prompting. Let's give it. Fine. I don't know. Okay, fine. So I'm able to connect it now. See, if I'm not able to connect, you have to come to the networking and check whether your network security group rules are allowing the 3389 port traffic. Okay. So once after it is logged in, I'm going to verify what is the gateway, what is the subnet mask, and close it down.
So the endpoint
Can
come
share,
only for user. Sorry.
Yeah. So you both overspoke. I mean, yeah. Go ahead. Come again.
The
with your
endpoint concept
the endpoint.
regards to the VPN Express, right? So regards to the endpoint.
Oh, with regards to endpoint, you are talking, right? Endpoint also uses the private connection. Yeah.
That's also part of Azure, right?
Yeah, it is also part of Azure. There are a lot of other services. Okay, so I got your question. So here, when you want to use the different IP addresses or Azure thing, yeah, you're right. Service endpoint, private link, all these uses private IP address.
Yeah, that is to connect for on-premises to Azure.
Yeah. So even for VPN gateway, express route, even within Azure, also from Azure VM to any service or Azure VM to on-prem, the specific services you can use private IP address. Yeah, you're right. Okay, so public IP addresses are mainly used for if you talk about service wise, it is mainly used for virtual machine NICs, which needs to be connected to internet public, or for example internet facing load balancers and VPN gateways, and then app gateways, application gateways. So these are all services which products and services which needs public IP address. Okay, even you have intranet load balancer. Okay, that is also there. Local or intranet load balancer, which is not public facing. Okay, fine. So now after logging into the VM, I want to show you a couple of things: the network gateway and the network ID plus the subnet mask. So if I go and say ipconfig/all, I want to specifically look at the gateway. It is 129. So this is development VM. So in our calculation, 129 is the 129 is the gateway. So that is what we expected, and that is what we are seeing in the system. And what is the subnet mask? 225, 255, sorry, 255, 255, 255.192. And that is what we expected. Perfect. Okay, so this is in line with our calculation, and whatever we are seeing in the system, it is pretty much the same. Now, we have just started with the basics, right? VNet and subnet, and we have seen how to do a small calculation and how to derive it. Now, maybe after the small break,
Stan,
yeah, go ahead.
Stan, one question.
Yeah.
Yeah, you said within Azure we can use the private IP, right? So from this server, if we can do MSDC and using that
Yeah, yeah.
private IP,
Sure,
connecting
sure.
other servers.
Yes, yes. So from here to this machine, it should automatically allow. Let's see, what is the IP address? Oh, we created a Linux machine, right? Yeah, I think we can do that. We can try and use the PuTTY tool. Let's try that. So 196. So I want to download PuTTY, and when I download, there will be
No problem. Leave
fine,
it
fine.
stand.
No, no, that's
Just
fine. That's
connecting
fine.
it should
Okay, I
be.
see. There is a point. There is a good. That is a good question, and how it works is also we need to understand.
Through local RDP it will work, right? So
Yeah,
same
yeah,
range. It will,
yeah. Right, right. In our on-premises, yeah. Likewise, in cloud also, the local range should
Yeah,
work.
yeah, that is okay. No,
Yeah,
if it is working means then it is okay.
yeah, yeah. Let's
And
try
one
that.
more question, like,
Yeah. Go ahead, go ahead.
uh, so we are using this public and private IP. So by default, we have two NICs in each server. Or
No, no. It is only one NIC. So there is a NATing that happens.
okay, okay. So, but if you're logging and checking this IP configure, it will not show this NATing IP, public IP.
No, it
So
will
only
not show
the
the
local
public IP. Yeah, it
private
will
IP,
show
right?
only the local one. Yeah, yeah.
Okay, okay.
But there is a mechanism to see that. Okay, I'll show you. I'll tell you how to do that. There is a way on how you can. Okay, let me re-log in because I've just enabled it.
Stan, so you have done the remote desktop by using the private IP, right? So
No, no, public IP.
how it work? Okay. So what IP have been used?
20.163.135.214 on the top. If you look at the RDP connection here, you can see what I have used. Here it is.
Okay, 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 fine, yeah.
I mean, I just purposefully did that. See, most of the people will start trying using the private IP address, right? So I just want to ensure that we are clear on that ask. So now let me go and download the PuTTY.
Stan, I have a question.
Yeah, yeah.
So once you reboot the VM, that dynamic will be gone or it will
No,
be corrupt?
it's not on each reboot. See, sometimes if you are keeping your machine idle or offline, or kept, if you power off your system and keep it idle for a long time, sometimes it might assign that IP address after a particular address lease period. So there is a default DHCP address lease, right? If you are keeping your systems
So that's
beyond
why.
that, yeah, yeah.
So that's why we put for static.
Correct, correct. If you want to have that IP address retained as a permanent IP for that system, for your application, you need to have a static IP.
Static.
Yeah, yeah.
Okay.
So now I can connect to that machine. Then let's see. This is the IP address. Open, accept, and to. So it works, okay? And to test VM01. And
Okay,
even
okay.
if I
Thank
want
you,
to,
Stan.
no problem. Yeah. So if I want to check the configuration of that system, yeah. So it is the IP address. This is the broadcast, and you can also see the all the details, subnet mask, and so on. Fine. So now let's take a break, and then when we come back, see, okay, let me explain how it works. See, any port, any protocol within that virtual network, which means across the subnet, production, development, and test, there is a rule that allows that. If you want to deny that particular rule, you have to write a rule which is having lower number than 65,000. So 65,000 range is for the default rules, right? And this is the rule that allows that connection. So from the development VM to the test VM between different subnet, right? So it is allowed from the same VNet, all the traffic is allowed. And in some cases, as a customer, they will ask you to deny some traffic. For example, let's say instead of prod, development, and test, we have a different scenario. Like we have uh, web application, middleware, and database. So from web server to database, they don't want to have the connection. From app to database, they don't. I mean, they want the connection. So similarly, they want to restrict the traffic from one layer to another layer. So if you want to override that, then you need to write a rule to specifically allow connection only from web to app, app to DB. So if you write a rule lower than this number, that will take more priority and precedence. Okay, so for your question, by default, all the systems within that VNet can connect to each other. That is based on the default rule. Okay, fine. Let me start the timer, and when we come back, we'll discuss more. Let me stop the recording and let's resume the session. Okay. So we have been discussing about the basics of virtual network and subnet so far, and also we saw how the IP addresses are getting assigned, followed by how the traffic is getting allowed, or the traffic is being default. By default, this is the traffic that is allowed, right? So now let's talk about few more important pointers here. So when you go and get a network interface mapped to IP address, if you look at the IP configuration, there are a couple of important things that you need to carefully look at. So let's see, allocation is dynamic and associated this. So let me go to the properties. Okay, fine. Let me go to overview. Okay, accelerated networking is all fine. So we used to have two different stock keeping unit, the basic one and the standard one. Let me try to show you that here. Let me go to network interface. Okay, let me create it. So see here, when you go and create IP, when you go and create a network card, if your customer is asking for IP v4 and v6, you can select both these options. Okay, so that it will support both IP version 4 and IP version 6. And if they need a static IP address, you can go and select this. And you can also pre-create this network card even before the system is created. So when you go and create a system, you can assign the same network card on the networking screen, and you can keep using it. So previously there used to be a couple of options under the network interface for the stock keeping unit, but now if you look at the public IP address whichever you are using, when you go and create a public IP address, you get two options. Okay, and the two options are basic and standard SKU. Okay, and again here in the IP addressing, you can either choose IPv4 or IPv6, but your network card can support both IPv4 and IPv6. So now this is very important, the stock keeping unit on your public IP address. So when you go and create a public IP address for a particular requirement, there are two options that you get: a basic stock keeping unit and a standard stock keeping unit. So you can consider this as a licensing model or a kind of differentiator between two different options. Now, when you go and create a stock keeping unit, by default, under the IP assignment, see when you choose basic, you will get two options. You can either go with static IP address or you can go with dynamic IP address. So you can choose between these two. So basic will allow you static as well as dynamic. But if you go for standard SKU, you have no option. You will get only dynamic option by default. See, you will not see the option to, sorry, you will get only static option. You will not see the dynamic option here. So this is very important thing. You won't have the option for dynamic option in standard SKU. And again, the network traffic. So if you go to the basic one, okay, so if you go to the basic one, if you scroll down, you will not have the option to go with Microsoft Network and the internet option. See, whereas if you go to this standard option, you get two preferences. Either you can route your traffic through Microsoft Backbone Network or the internet. See, as you know, Microsoft is the current largest network provider in the globe. Okay, they have got a lot of network connectivity across the globe. They have their own physical cabling that connects the global network. So they have their own physical connections from one region to another region, and they have redundant connections also. So they are the largest connector, I mean, network connection provider. So I think this is little old data, but still, if you look at here, they have got 165 miles of fiber connection across the globe, and they are connecting each of their data center on their own. So here Microsoft gives you two options. You want to use Microsoft own network, or if you want to go through the internet. So if you are getting internet connection, then you will pay the internet provider for the bandwidth and the data. And if you are using Microsoft network, it is comparatively less cost and it is more secure, because it is, your data is not going outside of the Microsoft networking infrastructure. It will stay within the Microsoft internet routing infrastructure or the networking infrastructure. So you get the option to go via Microsoft network or the internet. Here it is by default, the internet is what will be used for the network traffic on the basic SKU. And the very important part is the availability. See, if you are going for basic one, you will not get option to choose a zone redundant public IP address. So your IP address is only limited to a single data center. But then if you are going for standard SKU, your IP address is zone redundant. So by default, it is redundant across your availability zone. Even you can select a particular availability zone for your public IP address, but by default, it is zone redundant, which means even if one data center goes down, your systems on the other data center can still be accessible using the same public IP address. So it is not zone redundant. So it is confined to one data center only. And the next important point is the tiering. Okay, so you can have a public IP address which is tied to a regional or a global one in standard SKU, whereas in basic it is only a regional SKU. And the last important point is the security aspect. By default, in basic, all the traffic are open for inbound by default. Okay, whereas in standard, it is secure by default. You have to explicitly allow the traffic whatever you want to have for the inbound connections. So standard SKU is more secure than the basic SKU, and it is more available or more redundant than the basic. So if you are going for a very highly sensitive system or an application, always prefer standard SKU than the basic one. Basic one is little cheaper, but it is not as secure and stable available as the standard one. So always prefer standard for more critical workload, whereas basic is for a cost optimized workload. You can go for that. And so basic, if you are talking about which resources can be tagged to basic, you can assign a VM network card, VPN gateway can be tagged, application gateway can be tagged to basic, and even an internet facing load balancer can be used for basic. Whereas for the standard, I think again it supports most of them. Network card and then public load balancer and all those stuffs are mainly used. But then for the VPN gateway and app gateway, basic is still the option that is available, because it is confined to a data center. Because VPN gateway, it is a physical, it is a stuff which is attached to a physical device on that particular data center. So you cannot use the standard concept for these two, but for NIC and public facing IP addresses or public facing load balancers, you can use the standard, and which is much more robust and good option. Okay, this is a very good comparison you should be aware of. Okay, even when we created the load balancer also, we saw these two options. The options that we have, the characteristics that we have discussed, it is applicable for even the basic and standard comparison on your load balancer as well. Okay, now coming to the actual scenarios, right? So why, I mean, what are the different use cases or scenarios that the customer will come and ask us? So some customers, they will say they need a dedicated private subnet, and they will say the private subnet will be used for database, application, middleware, and so on. And then they will ask for dedicated private public subnet, and the public subnet will have the public facing services like the web servers or the web applications and all those stuff. Okay, whatever the public facing thing. And there is another scenario where a customer will ask all their services should have to be only private, and it will have to connect through the VPN gateway to on-premises, like a hybrid cloud scenario. And in some cases, customer will ask for what you call multi-cloud scenario, where you will have a mix of public subnet as well as private subnet, and you will also have some systems which connects to internet and some systems which connects to the third-party services and the local Azure services, third-party cloud, and so on. So in this one, in dedicated private subnet, you can also connect to Azure services as well, not only on-prem. See, when I say on-premises, I'm talking about some application which will be still running on mainframe, Unix systems, and so on. Okay, you will have some systems which are still remaining on your premises, which needs to connect to the Azure application. So these are the different three scenarios that we generally come across when you go and create VNet and subnet. So you might have a dedicated private subnet, dedicated public subnet, and I'll show you how to do that. Okay, and you will be able to understand it. So far, so we have discussed the basics of networking, and we discussed about the 5 or 6 important pointers on why we need to do networking, and we did a small subnetting calculation on how to derive the VNet and how to derive the subnet, and then we got some more practical understanding, right? So any questions so far on what we have covered? And also we covered about the 5 IP addresses that is needed for Microsoft reservation. Okay, there is no question, right? Fine. Now let's go and talk about a little more advanced stuff. So now I have got one virtual network. Okay, and I'm going to create one more virtual network in the same region or different region, and then we'll see like how the interconnections will work when you have multiple VNets and multiple subnet in different regions. So now this VNet in East US, let me create one more VNet here. Okay. So I'm going to create it in the same region. IP address, I will use a different IP address. So this time I will use 172.16.0.0. Think /23 is fine. Let me edit this. I will go with 172.16.0.0/24. I'll use the first set here. Okay, so now let's do this. Let's review and create it. Suppose I have a customer who says I need more IP addresses in that VNet, whereas I don't have enough IP address in the range that I have created, in the address space that I've created. So in Azure platform, you have that flexibility. Okay, you have that flexibility, you have the room for growth. Whereas in AWS, that option is still is not available. So here, Azure VNet is a very flexible address space, and you have a lot of room for growth in your address spacing. So how do I show that in practical here? See, if I go to my first network, suppose my address space is fully utilized and customer is asking for one more IP address range. So I can go and add like 198, 192, 168, 1.0/24 here. That will be allowed. Even if I need something on different class range like class B or class C, even that can be done here. For example, I can go and say 10.0.10.0/24. Even that will be allowed here. So that means you can create multiple address spaces in the same VNet itself. So that is how it is CADR concept. It is classless interdomain routing value. So it allows different IP address spaces from different classes. So you can have 10 range, 192 range, 172 range in the same VNet itself. But only thing, when you are trying to interconnect the virtual network, it should not have overlapping IP address. For example, if I have the same range in another VNet, so it will not allow me to go and create a peering or interconnection will not be allowed. So I'll show you. I'll show you how the error will come, and then I will fix that. Okay, for now, this is the understanding you should have. You can keep adding more address space, and it can be in different class range also. Okay, let's come back. So it has created. We have created Anto VNet, Anto VNet 2, and these both are in East US. Now I'm going to create one more virtual network in complete different region. Okay, now let's see. Let's go and create something like Stan VNet 001. I'm going to create it in maybe West Europe or London, UK South. Okay, in this region, I'm going to use the same range. Okay, for example, 10.0.0 range. And within that, I'm going to have a subnet, which will be an overlapping subnet as that of the first VNet. Okay, let me just go and define it here. Save it. Okay, I'm purposefully creating the same subnet range in a different VNet. By default, it will allow. Okay, you can have your own subnet range in different VNet. It's a separate logical. It is logically isolated from each other. So you can have the same subnet range in two different VNet for the same subscription itself. But only problem that will arise when you go and try and interconnect them, or when you go and do a peering between them. That is when you will see a lot of challenge. So let's see. Let's wait for the VNet to get created. It will create without any issues, but only when you go and try and do an interconnection or peering, then that's where the issue will start. Okay, so with your understanding should be, you can have the same IP address range in two different VNet. So each VNet is a logically isolated segment. Can be used in two different VNets in the same subscription. Okay, so this is the understanding you should have now. So now if I want to connect this VNet, okay, for example, I want this VNet and the other VNet to connect to connect through the Microsoft Backbone network. See, by default, if I have a VM in this Stan VNet, let's say I have a VNet here, let me create a virtual machine. Let me go and create a VM. Okay, subnet Stan VM001. Let me just do this. Sorry, I have to select the region here. I have to select UK South. See, when you change that region, a lot of stuffs might get re-entered. Okay, that's fine. I think it says it doesn't match. I think I entered it wrong the first time. I think my laptop is getting heated out and what is wrong? Okay, fine. So now let's try to go to networking. And here I have to choose the stan vnet, default subnet. This is all fine. Review and create. Okay, 1 second. Okay, fine. See, as I told you, these VNets are separate from each other. It's like a logically separate network from one another. And if I want to connect one VM from one VNet to another VNet, by default, you can establish connection through the internet via the routing. Okay, and if I want to connect it through the Microsoft Backbone network, then I need to establish one more particular connectivity. So we call that as VNet peering. Okay, if you want to interconnect two different virtual network, this is a important point coming from exam perspective as well as interview. Most of them ask this question about the VNet peering. If you want to have a seamless interconnection between virtual network, you need to do a VNet peering. So if I don't have VNet peering, if I have VNet 1 and VNet 2, and if I have VM1 and VM2 in two different VNet, by default, the connection from VM1 to VNet 2 will happen through internet route. But then if I want the two VMs to interconnect between each other using Microsoft Backbone network, then the easiest ways to achieve that is by creating a VNet peering. Okay, so if you go with VNet peering, sorry, yeah, if you go with VNet peering, you will get two different networks connected each other. Enables seamless connectivity between virtual networks. So once after I create this VNet peering, by default, or the traffic will flow through Microsoft Backbone network. So when you go with the Microsoft Backbone network, what is the benefit here? You get very good bandwidth, you get higher connectivity speed, you can have the traffic within Microsoft networking, within Microsoft data centers, and there is no public IP, public internet involved here. So that means you don't need a public IP address for connecting between two different virtual machines. Let's see it in practical and I'll come back here. So first, I'll go to the resource and see what IP address it has got. Fine, it has got 10.0.10.4. Now, if I go and try and create a peering, okay, from Anto VNet 1 to Stan VNet 002, there will be error. Okay, see, let's try this first. From Anto VNet 02 to Stan VNet 001, I'll show you the peering. It will automatically work, or it should work without any issue. So this one is a bidirectional peering. Okay, that means when you create the peering, you get the option to do the two-way connection. So allow traffic to remote virtual network, and then it says allow access, allow traffic. Both of them, you can just do that. See, if you want to do some gateway transit, I'll come to that point little later. But now let me just copy paste this. So this is the reverse connectivity from the other side, from east US to UK network and from the UK network to East US. So two direction. So it is asking which network you are going to connect. Currently, I am doing it from Anto VNet 02. I want to connect it to Stan VNet 01. And again, I want to allow the traffic here. And then click add. So now there is two peering getting created, one from East US Anto VNet 02 to the London data center Stan VNet, and from London VNet to East US VNet 2. So both connections are getting created. If I go and check it here, you can see that it is also creating a one more peering connection now here. See, it is connected now. So now if I have a virtual machine in Anto VNet 02, it will automatically connect to Stan VNet 001 because I have a VNet peering. I'll show you that. And if I try creating a peering from Anto VNet 001 to Stan VNet 001, you will get an error. The reason is both the VNets has got the same address space. Okay, let me try and show you that and then show you the error.
Same way too, by default it will be connected. So VNet peering is not required.
No. By default, that's what I clarified here, right? If you have two different VNet and two different VM, it will connect through the internet only. It will not it will not allow you to connect because the systems will have private IP address, right? So it will not work.
If it is in the same subnet, it will not work.
Even if it is in the same subnet, it will not work. See, VNet is a logically separate network. So VNets are logically separate from each other. It won't work. So even if you have the same IP address range, it will not work. It's separate from each other. Okay, so now let me just add this. See, suppose if I have, see, it says that there is a overlapping address space 192. It says two more overlaps with this. Let's fix that. Okay, so it will clearly show you that there is an overlap and it will not allow you to connect. So let's fix that issue. See if I go to the virtual network. So the easiest way to fix that is remove the overlapping address space, this one, and then save it. If you have any systems created in that address space, it will not allow you to delete it. So you have to delete that VM, you have to deallocate that, and then only you will be able to remove that address space. If you have some systems up and running, you have to deallocate those, and then only you will be able to delete, or else you have to change the IP address to different IP address and then delete the address space. Now, if I go and select it again, it will work. Okay, so it will not work on the fly. You might have to refresh. Add it now, it should work. My God, okay. So this is Anto VNet 01 to Stan VNet 01. And there is one more interesting stuff you might get as an error. I'll tell you what. There is OS level firewall. Okay, so that I'll come to that part now. See, if I have a subscription outside of my, if I have a VNet outside of my subscription, I have one more option to interconnect them. See, for example, if you go to every resource in Azure, it will have a resource ID. It will have a unique ID. So we call it as Azure resource ID. So this is what it is. Okay. So if you just see this, each and every resource in Azure will have a unique ID. We call it as ARI. Okay, this ARI will have a format. So if you look at here, subscription followed by subscription ID, then resource group followed by resource group name, then whether it is a compute or a network or a database or whatever, followed by the virtual network name. Okay, so each and everything will have similar format. Subscription followed by subscription ID, and then it will have resource group followed by resource group name, and finally it will have the provider, whether it is a network provider or a compute provider or a database provider or whatever, and then finally the name of the resource, VNet name. So this is a kind of resource ID that we generally have. So it will have the subscription ID at the starting. So it will be a unique name, unique ID. So if you want to create a peering, you can just copy this from here, and then you can also use that for peering if you're doing it across different customers, across different subscription. You might have different application from two different customers that needs to talk to each other. In that case, if you want to do peering, you can enter the resource ID like this. It will automatically pick it. Okay, so it can be across different customers, different subscription. So now I have just added it.
Stan, one question.
Yeah.
Is it same like ARN in AWS? Right?
Yeah, it's same like ARN in AWS. So it says there is a error. Okay, so it says one peering is unable to connect the address space in the original and must be synced. You have a contributor. Okay, so looks like there is some. I have not refreshed it. Okay, let's see. See, it has created one side. On the other side, it did not create. Let me try to do it again. Sorry. Okay, let me recreate it. I should have refreshed both the screens. Okay, go to peering. Let's delete it. And most importantly, see, if I want to interconnect two different network in two different geographical regions, I need to involve a lot of stuff. I need to connect, and I need to create a VPN gateway. I need to do routing and all those stuff. Only then I'll be able to interconnect. So here it works pretty seamlessly. Okay, so let me show you this. So is there any overlap? No, right? So this address space is completely 10 range. Okay, so this is peer to the other network, fine. So here it is 192, perfect. So it should work. Okay, let me go to peering. Let me try and do it. Stan VNet 01 2 Anto VNet 01. Okay. So if you want to deny the traffic, you can also deny the traffic by unchecking these options. Okay. By default, it will only allow access, but if you want the traffic to be stopped one way, you can also stop the traffic by disallowing that. Now let's try and create it. Okay, it has created it now. So if you have an overlapping IP address, it will not work. Okay, so your IP address space should have to be unique from each other. Only then you can create a peering between these two systems or these two network. Now,
So you paired, sorry, one question. So you paired with class B and class C, correct?
Yeah. Class A and class B and class C. You can do whatever. See, I've created two different peering, right? So this one has got class B, and then I have connected it with class A. Similarly here, I've got a class A range, class C range connected to a class A. That should be fine. Okay, you can interconnect them. Now, what I'm going to do is I'm going to create a VM in the other location. Okay, so here, oh, we already have one. So let me connect to this. So the beauty of this concept, right? So let me show you this first. Sorry, what happened? Okay, let me connect to this first through public IP address, and then I'll show you how to do that using private IP address.
The same VNet, a different subnet will work, is it?
Yeah, you can have different address space in the same VNet itself. Yes. So let's complete this and then see how it works. Okay, and what is the
Normally
difference?
on-premise, you have to do a lot of things too.
Yeah, a lot of routing and stuff has to be done. Even here, behind the scenes, Microsoft does that for you. Okay, so let me just log in here. So I'm in this particular system. Okay, so you know that for each of your operating system, you have a OS level firewall. Like in Linux and Windows, we have different IP tables, a firewall and stuff. So you need to be mindful of that. So there is a OS level firewall that will block the traffic between the subnets or between the ranges. So in Windows, we call it as Windows Firewall or Windows Defender or whatever, right? So we have to go and disable that. And see, for example, when you're doing some testing, you might think that it is not working, but it is mainly because of the firewall. Okay, so first thing you need to check whether the firewall allows the ICMP ping. So now I want this system, okay, 10.0.10.4. So from here, I have this system, which is in completely different IP address, right? 192.168.0.188. So here, if I say 10.0.10.4, it will not work now. The reason is it is not because that it is in different subnet. We have created peering, right? So it should work. So where exactly it is blocking? It is blocking at the Windows Defender firewall level. Okay, so if I go and allow the private thing and then check, let's see. And again, we are connecting through the internet, right? So let's see one by one. Let's enable it one by one. Okay, it's still not reachable. And how about the Windows firewall on this system? Let's check that as well. I think we disable that. Yeah, it is off. Public is off. So here, let us go and allow the incoming connection now. Public and disable. Let's see. Now let's go and check the connectivity. See, it has started pinging. So I'm on which machine? I am on 192.168.0.188 machine, and I'm able to reach the system which is completely on different class, different range. Okay, and that is because of the VNet peering. Okay, so let me show you the other direction also from here. Ping
Very
192.
interesting.
Yeah, 192.168.0.188. Yeah. So how this works? So if you go and check the trace route, it will be directly interconnected between each other. Okay, so if I just say trace route or trace it, I'm not sure which one is the command. Let's try this one first. I think trace route is the command for Windows. Yeah, it works. See, it went in just a single hop, but then there is a 75 minutes later, 75 millisecond latency, but it went in one single hop itself. So this is working because I have a VNet peering connection established. So if I go and delete that VNet peering, things will stop working. Okay, so it worked in just a millisecond. It went directly to that system as a single hop. So now if I go and remove that peering, let's see what happens.
So the VNet peering works only that Azure platform. So on premises to Azure, it won't, right?
Yeah, it is a different concept. Yeah, we have to use different technology, different product for that. But now, yeah, see, when I delete it also, it deletes both the connections bi-directional. Okay, now if after this is getting deleted, you can see the ping will stop on both the machines. See, it has started requesting timeout. One side of the connection is already down. So here it is requesting timeout. And again, here also, you should start seeing a request timeout here.
Last time I have one question.
Yeah.
Yeah, see, if you delete the VNet peering, then it will be give a warning message, right? It's already running with the VM and all that. See, in case if someone has deleted it, how do we troubleshoot it? In if you
Yeah.
see,
So
if you have
I'll
a one or two VMs, it's
correct.
very
That,
easy.
yeah. That is
But
the same
if you have
question
a
that
multiple VMs,
yeah, that is the same question that Subramani had, right? So what are the ways to have traffic monitoring, how the traffic flows, and then how do we check that? All those things will be done using Azure Monitor or Network Watcher, Network Tapping. There are a lot of tools to find out where exactly the traffic got interrupted or where exactly the problem arose. So we'll see that.
okay.
So here, if you look at the one side of the connection is still working. Looks like it is still not request timed out. Yeah, it is about to be. So here, if I do a trace it now, see, it will go through the internet. It will try to go through the internet route. It will take ages to connect. But when I have the peering back again, it will start working. Okay, so that is how it works. If you have the peering, it is just a one hop to the destination. It connects through Microsoft Backbone network. Whereas if you don't have peering, it tries and connects through the internet route. So, but then it will take a lot of time, and it's not that easy to get that established. Now let's go and understand a few more things on this stuff. Okay, let me just put all these things to the bottom.
Stan, actually, I
Yeah.
missed this subscription ID. So whenever we are doing this pairing, we need to give this subscription ID for
No,
another
no, no.
user.
So no, Sindel. So if you are doing between customers, the VNet will not be available in the drop down, or even the subscription will not be available in the drop down. So if you are doing it between customers, and if you want to interconnect two different set of applications together, then you need to get the resource ID that will have the subscription
Okay.
details and so on. Otherwise, it is pretty straightforward. If you're doing within your organization, you will get the subscription and the VNet name in the drop down itself.
Okay.
Yeah.
Also, this VNet peering is working across RG, right? Resource group.
Yeah, it will work. It will work across resource groups. It will work across the region. Yeah. So that is what I'm going to come now. So there are two different concept: local VNet peering and global VNet peering. You can also create peering even within the same region, and you can also do it between the region. So whatever I showed, it's for the global, right? I connected East US and London, UK South, right? You can also do VNet peering. If you have the VNets in the same region, then it is called local VNet peering. And if you're doing it in different region, then it is called global VNet peering. You can also do both of them. Both of them are supported. So here, yeah. So now there is one more way of connecting two different virtual network. So one is VNet peering. There is an option called VPN gateway. So if you ask me how exactly VPN gateway is going to help in a particular customer requirement. So here in VNet peering, whatever the traffic that connects from one VNet to other VNet, it is not encrypted by default. It is not encrypted by default. Some customers, they will say whatever the application to application traffic within the organization or between the organization, and they want the encryption to be done in a particular connectivity. So if their data connections is secure, or if it is very critical for their business, then you can go with encryption concept. So if you need to establish encryption, then you need to go for VPN gateway. VPN gateway is the concept where you can go and get the encryption enabled. I'll show you how to do that. I'll show you that in practical. Okay, so VNet peering, it also supports local and cross region both. Both are supported in VNet peering as well as VPN gateway. And even you can do it in cross subscription also, between customer also you can do. Okay, and then if you ask me whether you can do it in cross deployment, we used to have ARM model, ASM model. We can do that, but now it's all ARM. ASM is almost deprecated. And if you ask me the limit, okay, so you can create up to I think 500 VNets, if I'm not wrong. Whereas here each VNet will need to have one VPN gateway. Okay, you can create up to 500 VNets peer to each other, whereas here each VNet should have one VP gateway or virtual private gateway or VPN gateway. So that is a requirement here. And okay, so in VNet peering, you are using Microsoft backbone network for connectivity. So, and again, you are connecting, if you're connecting two different VNet in the same region, there is no pricing. But between regions, if you are connecting, both inbound or ingress and egress outbound data are chargeable. See, instead of paying to internet provider, you are paying that to Microsoft. You are sending the traffic through the Microsoft backbone, and you need to pay for both the traffic between the region. If you are doing it, both inbound transfer and outbound transfer are chargeable. So ingress means inbound data, egress means outbound data. But here for VPN gateway, you need to pay for the appliance. When I say appliance, you need to create a virtual private gateway, a virtual appliance, plus outbound traffic is chargeable. There is no charge for the egress one, but you have to pay for the appliance, the gateway device, and the egress. I'll show you how that works in practical for the gateway device, and the egress traffic is chargeable. Okay, but here there is no appliance, there is no gateway. It's like direct connection between the two different region, and it works. And here the only challenge is there is no encryption by default, but you can do it. You can put a network virtual appliance, and then you can route the traffic through a software encryption device. You can do that, but here in VPN gateway, you get a lot of security encryption can be enabled by default. So here in VNet peering, there is no limitation as such when it comes to bandwidth, speed, and all those things. So you get unlimited speed here, or better latency here. Whereas when you send your traffic through an encryption device or through an appliance, then automatically limited bandwidth and then limited speed will come into picture. Okay, so speed will be limited, bandwidth will be limited, and there will be some latency stuff. And in VNet peering, there is no internet involvement. Data travels through Microsoft backbone network. So then there is no public IP needed here. Whereas here you need to purchase a public IP address from Microsoft and then use it for your VPN gateway. And then here it goes through the internet. Okay, and the next point I would say, like gets created within few seconds. This takes at least 30 minutes to get created. I'll show you how to get this created tomorrow, and we will see this VPN gateway concept in practical. So, but now we have seen the VNet peering concept, and with the same region and between the region. And if I just do it, like what happened? Yeah, it will ping request timed out. It has, the screen has frozen. So if you want to connect them again, what do you have to do? You have to, let me show you that. You have to create a peering and it will start connecting to each other. Let me show you this. Add peering Anto to Stan. So naming is whatever you want to give, you can just give Stan to Anto. See, if you are doing it between subscription or between customer, that option will not come in the dropdown. That is where you need to use the resource ID. Okay, fine. Get it created, add. So now within couple of seconds, these two connectivity should start coming up. And even you can take remote of that other machine from one machine here. I'll show you how to do that. Maybe it will also, MSTSC will also work. Not only the ping, see, it has come in very few seconds. Within 5 to 10 seconds, the connection has come. And if I want to connect the UK system from the US, I can also do that. Or the other way around. 192.168.0.188. See, it is prompting me. So not only the ping, even the, I think I entered the wrong password. So even the MSTSC and the other protocol will work. See, it is working. What happened to my keyboard? Yeah, it works. Yeah, so I could see it as connected using the private IP address. Perfect. So even if I do the trace out now, it will go in single hop. Yeah, go ahead.
I have a question like
Yeah.
for VPN gateway, only for the encryption only we are using it, right?
Yeah, encryption, and again, you have a lot of.
Global, you said global peering, we need that.
Yeah, no, even global peering is supported in VNet. I mean, earlier, maybe 4 or 5 years back, VNet peering was supported only in local and global. We need to go with VPN gateway, but now VNet peering is available in within the same region and as well as between the region. Both are now supported. So yeah, mainly for as you said, mainly for encryption. And again, if you want to have some cost reduction, see here, no, it's not cost reduction, because for the outbound traffic, mainly you will be paying to internet provider. Instead, you are paying to Microsoft. Yeah, mainly like security. Okay, security is better in VPN gateway by default.
Stan, does that mean for global VNet we can do it with VNet peering itself, right?
Yeah. So that's what we
Don't have
did,
to.
right? So we have this this VNet in US, and then you have this other one in London, UK.
Okay.
Yeah.
So we cannot
Yeah.
use that VPN gateway without the VNet peering.
I think your audio is very feeble for me.
Sorry,
Yeah.
I'm asking, like we can able to use directly VPN gateway instead of using VNet peering after VPN gateway.
Yes.
We can directly use VPN gateway alone.
Yes, we can use it. Yeah, that is also one more option to securely connect from one customer to another customer. See, VPN gateway, it is also used for Azure to Azure. You can use it for Azure to on-premises, and you can also use it for Azure to third-party cloud like AWS or other third-party cloud. So VPN gateway is multi-purpose.
Okay.
Yeah.
Stan, I have one question. Like
Yeah.
in the VNet peering, you said there is a basic and standard one, and for the standard only, this Microsoft backbone network is working.
No. That concept is for public IP address and load balancer only. So this concept, stock keeping unit, is for public IP address and load balancer only, not for peering.
Okay.
Yeah.
Okay. And I have one more doubt.
Yeah.
Like you mentioned this address, right? Address space.
Uh-huh.
In any VNet, if you can create this address space,
Mm-hmm.
that mention about the different network in this particular VNet.
Mm-hmm. Yeah. We are talking about the different IP address range we are using in that VNet. Yes.
Okay, so even we can create one address range very first, and after that we can create one subnet or subnet is not considered as address space, right? Is it considered?
Yeah. See, subnet has to be within the address space what we have defined at the VNet level. Yeah, whatever VNet we have defined. See, if I'm going and creating a subnet, it has to be within these ranges. For example, if I'm going and saying I need a 192, 168, 100 or something, it will not work. See, it has to be within the CIDR range that we have defined. See, for example, I'll say test subnet, or I'll say check subnet. And if I say 192.168.100.0/24, it will not work. So it says the address range is not within the virtual network address space. So whatever the range we are giving, it has to be within the address space here. So for example, you have 0.0 and 1.0. If I go and create 1.0, it will work. So for example, let's say it is 1.0/24 or 23, it will work.
Okay.
If I want to have,
so by default, this address space will take whenever we are creating VNet, or
no, we defined it, right? We have to define it. So we went with the calculation and we defined it. For example, if I want to have 192, 168, 100.0, I can also add that here. Okay, and then once after I save it, then you can create subnet in that particular address space, whatever we have defined at the VNet level.
Okay.
Yeah.
And whatever the address space we are creating here within this VNet, it is all accessible. Like this connections, communication between this address spaces.
Yeah. By default,
working, right?
by default, by default, all the systems within this address space and at the VNet level will work, because there is a rule by default which allows connectivity at the VNet level. We'll discuss that routing, firewall, and other advanced stuff. We'll discuss tomorrow. Yeah.
Okay. Thank you.
And again, just to clarify, because some of you were interested in the connection monitor and all those things, right? See, when you're trying to connect from here, see, for example, I have one machine here and I want to connect a particular IP address, let's say 10.0.10.4. Okay, I want to do ICMP ping. And then you can go and check connectivity, next hop, port scanning, and all those stuff, and then run a diagnostics. Since Subramani and Mani, I think a couple of you were interested, right? Where exactly to go and check some connection troubleshooting and all. So I'm just quickly showing it. I'll explain it a little later, but just for the interest of time, I'm just showing something quickly here. And then it will tell us whether it will work or it will not work, or where exactly the problem is. Okay, so yeah, meanwhile, it will take some time. It will have to install the extension on both the virtual machine. Okay, so once after the extension is installed, then only the diagnostics test will be running. Okay, it will take 2 or 3 minutes. Meanwhile, any questions you can go and ask. Today I've done with whatever I was planning to cover. So we will continue to discuss network tomorrow and even for the next 3-4 classes.
Okay. And one question. Like
Yeah.
VNet will come in place only during the time of creation of this private IP address and connecting this.
Yes. Yeah.
Establishing communication between the our companies.
Yeah.
Right.
Yes.
Okay. And even we can extend this VNet to on-prem using this VPN gateway, right?
Correct.
Okay. Thank you.
Yeah. Okay, the network watch. Yeah, go ahead.
Actually, we are working large network.
Mm-hmm.
So, infrastructure and network team, everyone is under the infrastructure team. So we are supporting AD and Azure now. If we need to some address ranges for 20 IBL something, I need yearly discuss now. So through network team only provide for us now.
In on-premises, you are true, Rajesh. That's how it works in the on-premises. Okay, let me reshare my screen and I'll show you something. Just a second. Just 1 second. Let's see.
Is pairing different Azure or the same organization or different organization? VNet pairing.
Just a second. Yeah, it can be done between organization also.
Okay.
Yeah. So let me just show you this. I know that there is some customer specific information here. Let me stop the recording for a minute. Evolve to IP address management tool. Like we have what we call info blogs or different tools through which network administrators started managing it. Even in your system itself, if you go to your role, add or remove roles, nowadays Microsoft also provides you a tool to do the address management. Okay, if you go to add or remove roles, you can see that there is a IP address management stuff. So if you go to the features, you will see that IP address management server is there. You can make this server as IP address management server, and you can manage the different subnet and range and all those things. That can also be done. But to clarify your question, yes, in on-premises, in physical network, there is a network engineer or an administrator who manages the IP range. But here, it is the cloud operations team who will manage the VNet creation, subnet creation, and the management.
Okay.
So that particular, because it is logical concept, right? It's a virtual networking. It is not physical networking. So you need to be aware of that. So now coming back to the test that we ran. Okay, so outcome, you can see that it is able to connect, and the average latency, minimum latency, whatever the number of probes, outbound connection is allowed. And next stop is the virtual network peering. See, it clearly tells you through which route it is going. It is going through the virtual network peering, and it is going through the system route. And what is the next hop? It directly connects to here. Now, if I go and delete the VNet peering, it will stop the traffic, and it will try going through the internet route. Let's try that. Yeah, just a second. Let me delete this 1 second. Which one? This one. Okay. Now let that get deleted, and we will try to run the connection again. See, it also gives you a topology diagram also. So from where to which network, and from here where it is connecting, and all those stuff. So let's try to run the diagnostics again. We'll do that. Yeah, go ahead.
Yeah, if you are doing a connection troubleshoot, the agent will be installed in both the machines.
Yes.
Like in the particular virtual machine. But
correct.
Before, in case the virtual machine is not reachable, then how the agent will be installed in that virtual machine?
Okay, let me answer that. So you mean to say the machine itself is down, and you cannot install the agent, right? So see, the agent installation, it is done at the Microsoft layer level. So it is not happening through the IP address that we have defined. See, it is the agents are stored in Microsoft Backbone server, the distribution server. Maybe they are using MECM or a different tool, and from there it is pushing using a different IP range. So it works like at the data center level, physical data center level. So not using the IP range that we have defined. Let me run the diagnostics tool now. Okay. Let me mute the line. Okay, there is a lot of background noise. Yep, sorry. So now we'll see that there will be some error, and it will tell us to go and create a VNet peering or a virtual network gateway has to be assigned in order to do the connection. So this is a kind of quick answer for whoever asked about the connection troubleshooting and what kind of diagnostics you are expecting. You can do a connection troubleshooting, next stop troubleshooting, port scanning, and all those stuff. So you can see that there will be error now. So it is failing. So the traffic is failing at the network security group level itself. There is no hop, there is no route. Okay, that is what it is saying. So you can go and do all these things to fix the particular connectivity check. So it will give you detailed report. You can, if you are able to find it, you can find it, or next level you can involve your senior team or the Microsoft team for that particular troubleshooting. Now, if you have questions in English, feel free to go and ask it first, and then I'll open the floor for asking questions in Tamil. Okay, I'll take that as no. Tamil la question da kelunga. Okay, if everyone is good for the content today, yeah, thank you all for joining.